So let's think about that. If I have an original and my perimeter of my original is 10, and let's say that my lengths are multiplied by 5. My lengths are multiplied by 5. So what would my new perimeter be? If my side lengths are multiplied by 5, that means my perimeter will also be multiplied by, that's right, 5. So our new perimeter, well, let's say units, would be how many units? That's right, 50 units. It doesn't matter what shape this is, that will be the relationship. Well, let's talk about our area. What if our area of this shape is 20 units squared? Well, that means our new shape, it's not just going to multiply by 5 the area, it's going to multiply by 5 squared times. What's 5 squared? Well, that's 5 times 5. Well, that's going to be 25 times larger. So our new area, well, 25, think about a quarter. 4 of them make 100 or $1, and you have 5 groups of 4. So that would be how many? You got it yet? That's right. 25 times 20 is going to be 500. 500 square units, because it's going to be 25 times larger. Awesome. Well, let's move on to the next activity. Please track with me while we read the directions. Activity 4. We're now going to explore the relationship between triangles that have the same angle measurement, but the side lengths are different. So that's what we're going to be looking at. So we're going to list the corresponding angles and the sides in the two triangles. Well, let's first talk about the corresponding angles. Angle PRQ, right here, angle PRQ corresponds with what angle in this triangle? That's right. Angle PRQ corresponds with angle ACB. PRQ corresponds with ACB. Angle ACB. And what are their degrees? They both measure 117 degrees. Perfect. Do you see another corresponding angle? That's right. Angle RQP is going to correspond with angle CBA. So angle PQ, sorry, that's an R. RQP corresponds with angle CBA. We want to make sure we have the corresponding parts together, and that means they're both 48 degrees. Do you see another corresponding angle? Yeah, our third corresponding angle is going to be angle RPQ with angle, since we started with R, we have to start with C. CAB. Excellent. And those are both 15 degrees, which is good because all those degrees add up to 180, which is how many degrees are in a triangle. So let's take a look at the corresponding sides. If we look at the corresponding sides in the two triangles, since R and P correspond, that means C and A correspond. What are those side lengths that are corresponding? That's 18 and 6. So 18, which is RP, corresponds with CA, which is 6. Interesting. What other parts correspond? Well, side 21 and side 7. That means that sides or segment QP, which is 21, corresponds with segment BA. And we need a line over it because it's line BA. And that one's worth 7, a length of 7. And we have one more corresponding side, and those pair corresponding sides would be 6 with 2. Notice I like to sort my corresponding sides with either shapes or double underlines or single underlines, and that's going to be helpful when we look at scale factors. So this is RQ, place it over here, RQ corresponds, that one's 6, corresponds with CB, which is 2. And you can put a comma in between these if you want to. Awesome. So those are all of our corresponding angles and corresponding sides in these two triangles. So how are these two triangles similar and how are they different? Well, they have equal what? What do you know are the same here? Oh, they have equal angles. Equal angles. And well, they're both triangles. Equal angles and shapes. If we wanted to classify these triangles, what would they be? Well, 117 degrees makes this, that's right, obtuse. And the three different side lengths makes that, that's right, scalene, obtuse, scalene triangles. So that's how they are similar. That's how they're the same. Well, how are they different? How are they different? They have different side lengths. And because of those different side lengths, 18 and 6, 21 and 7, 6 and 2, because of those different side lengths, they have different size triangles. So different side lengths and sizes. So what do you notice about the lengths of the two triangles? How would we go from 18 to 6? Those are corresponding. Oh, how would we go to 21 to 7? Or 6 to 2? Interesting. Is it the same number you would multiply by? Well, we notice that the corresponding side lengths have the same ratio. 21 over 7 is 3. 18 to 6 is 3. And 6 to 2 is 3. Do you remember what we call shapes that have, or values that have equal ratios? Equal ratios means they're proportional. Excellent. So let's write this down. Corresponding, meaning QP with BA and RP with CA, corresponding side lengths have the same ratio, meaning that they are proportional. The ratio of sides is, if I went from big to little, 3 to 1. All the ratios reduce to 3 to 1. Because these shapes have proportional side lengths, because all these ratios are equal to each other, 21 to 7, 18 to 6, 6 to 2, these shapes have a very special relationship that we're going to see on the next page. Please turn the page with me. So these shapes are called similar figures. So let's take a look at the definition, the symbolic representation, and an example. Similar figures. Definition. Figures that have the same shape but are not necessarily the same size. Sides are proportional and angles are congruent. So let's see what that looks like symbolically and with an example. So we saw on the previous page that triangle ABC is similar to triangle EFG. And we use this symbol, which is kind of like a kind of sorta, it's almost equal, it's really similar. It's a similar symbol. And the way we show that two different triangles are similar is I can have triangle CAB and a larger triangle EFG. And to show that these triangles are similar, I'm going to show that E and A are congruent by using one arc each. I'm going to show that F and B are congruent by showing two arcs each, meaning they have the same angle measurement. And I'm going to show that angle G and angle C are congruent by each giving them 3 arcs. And that shows that they're congruent or the same measure. When triangles have congruent angles, their side lengths are automatically proportional, which makes both the shapes similar to each other. Corresponding parts. Corresponding parts are the angles or sides that match up between the two shapes. The order the matching does matter. You have to stay either going big to small or small to big. So in our figure above, if I had segment AB, if I looked at AB, AB would be corresponding with segment EF. If I said BA, I'd have to say FE. So the order does matter here. If we wanted to look at segment AC, AC corresponds with AC with EG. And our last set of corresponding sides would be, well, we can take BC, segment BC, and since we did BC, we have to go FG. So those are all our corresponding sides. We also have corresponding angles. So angle A, because it's congruent to angle E, angle A is corresponding with angle E. And angle B is corresponding with angle F. And angle C is corresponding with angle G. And because they're similar figures, if they're corresponding, that means they're also congruent. And there's no symbolic representation for corresponding. We can just put and in between them or put a comma. So let's fill in the blank to see which make each statement true. I want you to read these with your group, so please pause the video for about 3 minutes. Pause the video for 3 minutes so students can work with their groups to fill in the blanks. Awesome, let's see how we did. If you change the dimensions of a shape to a new shape with a scale factor of 4, then the change in the perimeter, remember, lengths and perimeters are both one dimension, so they have the same change in scale factor of 4 also. Good. Number 14. If the change in dimensions of a shape to a new shape has a scale factor of 7, then the change in the area would be a scale factor of, that's right, it's going to be 49 because we want a square. Area is to the second dimension, so that's going to be that scale factor times itself, 7 squared, 49. If the change in the perimeter of a shape to a new shape has a scale factor of 49, remember that's one dimension, perimeter, then the change in the shape's dimensions, also one dimension, would be a scale factor of 49, the same. If the change in the area of a shape to a new shape has a scale factor of 36, then the change in the shape's dimension would be a scale factor of 6. Remember, area is a number times a number equals that scale factor. And it's the same number being multiplied, and 6 times 6 is 36. Or if you thought of square root of 36, that's also 6. Awesome. Great job, mini mathematicians. You have the rest of the period to be working on homework. Have a great afternoon. Do your best, be nice to everyone, and I will see you next class. Thank you so much for your hard work.